Hello everyone, this is Roger JeesSmith from the department of CSE. Hope you are doing good. Now, today's just a few concepts in data structures. Before that, data structures. What is mean by a data structure? From the word data structure, structure of a data. How will you structure a data? The data may be any characters, any integers, or anything. It can be any images. So we need to structure this data. What is the other name for structure? It may be organizing, arranging, like this. It will be going on. So how will you organize a data? How will you arrange a data? So data will be in any forms. For example, if you take integers, the integer data will be 1, 5, 8, 0, 10, 9. We don't know under which format which data comes first, we don't know. But here as of now some data is there. Some 1, 5. In which order it is? We don't know. Whether it is in ascending order, whether it is in descending order, we don't know in which order it is. So here 1, 0, 1, 5, 8, 10. Now it is somewhat structured. Now it is something, it is structured, organized. How it is organized? In ascending order. So this is nothing, sorting of data. So either in ascending order or descending order. Now again I need to find a data. That is nothing, search process. How will you search a data? So you need to compare from, I need to search 5. So I need to compare from starting of this, from 0, whether 5 is matching with 0, no, 5 is matching with 1, no, 5 is matching with 5. So I have found this element. Now I found this element, where this element is, where? So that will be position. So this is what data structure in short. So organizing a data, arranging a data, searching a data or finding a data, and I need to display this data. All these comes under this data structures. Now we'll go. Data structures. It is divided into primitive and non-primitive. Primitive is nothing, your data types. Non-primitive is your main data structures, whatever it is. Data types is character, integer, it goes on. Non-primitive, you will be having static, dynamic, and static you will be having linear, non-linear. Dynamic you will be having trees and graphs, everything. In linear, arrays. Non-linear you will be having linked list and queues, stacks, everything. Now this is just a outcome, outline of this data structure, how it is divided. Now among this, organizing a data, how it is structured, everything. So we will have some data for an example. 6, 8, 1 and 15, 2, 5, let it be. Now this is my data. I have some data. among this data, in which order it is. First, in which order it is organized. No order. Nothing is there. So we are going to organize the data now. How we are going to organize? Sorting. So sorting is nothing either in ascending or descending. Types of sorting: quick sort, merge sort, radix sort, shell sort. So these are few types of sorting techniques. So whatever you are giving as data, I need to arrange in either ascending or descending. Now we'll see one of the topic. Quick sort. We will go for quick sort. What is the method used in quick sort? First, 6, 9, 5, 4, 10, 8. This is stored in an array. Okay. Array, we will name the array as A. Positions 0, 1, 2, 3, 4 and 5. Array elements with the positions 0 to 5. Quick sort is nothing, just you are going to take a element called pivot element or key element. Okay, pivot element or key element. Using this pivot element, I am going to sort the given data. What is a pivot element? What is a pivot element? There are three types or three ways to choose a pivot element. What are the ways to choose a pivot element? One is, very first element will be the pivot element. Middle element will be the pivot element, and any random element will be the pivot element. So three ways to choose a pivot element. After choosing a pivot element in quicksort, you will be having a format. Once you took a pivot element, let it be P. If you take an element pivot, the elements which are to the left side will be in less or smaller number, and which are at the right, it will be greater numbers. So if it is 7, here 4, 5, 1, this is not in order, but when compared to 7, these numbers are lesser. Here 10, 9 and 11, here also the numbers are not in order, but when compared to 7, these numbers are greater than this pivot element. Now this is what your pivot element will be. So pivot element in the middle. After sorting, the smaller elements will be on the left side, and greater or highest number will be on the right hand side. Now after this, after choosing pivot element, here I have taken the pivot element as 6. Pivot element equal to 6. What is 6? The very first element. The very first element is pivot element I have chosen. Now after choosing the pivot element, what is the procedure to sort this? Now I am taking from this side as I said, pivot element, this side will be smaller and this side will be greater. So from this side, when I compare all the elements to pivot element, it must be smaller. So I need to compare from left to right. That pointer, let it be I. Next, greater from the next side or other side. So let the pointer be J. So I and J pointers I have initialized. I is nothing, you are starting. J is nothing, you are ending. So I need to go from 0 to till the end, J to till the first. This is what the quicksort first procedure is. Now I will be I plus plus. When I plus plus, when I need to increment I, that is the first condition. So I need to increment I when this pivot element must be greater, I mean from here the elements must be smaller than the pivot element. So A of I must be smaller than the pivot element I plus plus. Else stop it. Else you stop the pointer. Next, same time A of J must be greater than pivot element. A of J must be greater than pivot element. That will be J minus minus. Why minus minus? From J to reverse. Else stop. Stop the pointer. Only if it is greater you need to forward, backward. Only if it is lesser you need to forward. This is the actual condition. Now compare A of 0. This will be under for loop. A of 0 when compared to pivot element. 6, let it be. Next, go to I plus plus. What is that? 9 greater, else this condition will be there. So 9 is greater than 6. Stop. Now your I is here. Next, same time come from J. 8 is greater than 6. Go on, minus minus. 10 is greater than 6. Go on, minus minus. When it reaches 4, 6, condition false. Stop the J pointer there. Stop the J pointer there. When these steps are stopped, I is stopped, J is stopped, and one more, I must be less than J. I must be less than J. Swap I, A of I and A of J. Swapping procedure is something just normal swapping as we see in C program. Here as an algorithm you are going to have a swap function. You are going to swap A of I, A of J. When you are going to swap A of I and A of J? When these two conditions at else. Okay. At this condition I am going to swap this. After that, what will be the array? 6. 9 is moved to here and 4 is moved to here. So 4, 5, 9, 10, 8. Okay. Now again compare I plus plus and J minus minus. Now compare 6, 4, 5. Where this I will be stopping? At 9. Next, 8 is greater, 10 is greater, 9 is greater, 5 is lesser. So j stops here. What is here now? J is greater than I. J is greater than I. When this condition comes, if j is greater than I, again you are going to call swap function. What you are going to swap? This pivot element and the a of j. So pivot element and a of j. Pivot element and a of j. Now what will be the output? Five, 4, 6, 9, 10, 8. So this is pivot element. Compare this. Compare the format. The elements which are left of pivot element will be smaller, and elements which are right of pivot element will be greater. Is it so? You can see 5 and 4 less than 6, 9, 10, 8 greater than 6. Pivot element at the center. Now the same procedure, the whole procedure is now applied for this and this. Now the array is divided into 2. Here you are having 2 arrays, that is nothing, partitioning of an array. You are dividing an array into 2. First step. Now the pivot element position will be same till the end of your sorted array. Pivot element will be at the same position 0, 1, 2, 3, 4, 5. Pivot element will be at second position only, whatever it is, till the end. Now go to this array, sub array 5, 4. How will you sort this array? 5, 4. Take the first element as pivot element and here I will be forwarding. When I will be stopping? When it is greater than. So no element is there. I will be going on after 4. Again I will be there out of the array. If no element is there, out of the array. Next, compare j. J will be here only. Why j is stopped there? It is less than. If it is greater than means j minus minus. If it is not, j stops there. Now j and I crossed each other. Swap this and j, pivot element and j automatically. The next thing will be 4, 5. 4, 5. Now this array is sorted. Next 0, 1, second position. Second position will be 6. Again at the same time we need to sort this also, 9, 10, 8. How will you sort? Again the same procedure. Take 9 as pivot element. Now compare 9 with 10. I will be stopping here itself and j will be stopping here itself. Again swap a of I and a of j. That is nothing. 8 will be coming this side, 10 will be coming this side. Again next move on. Your I will be from 9, 8 is smaller, 10 is greater, I will be here. Next j, 10 is greater, minus minus, j will be here. Now after crossing I and j, j is greater than I. When this condition comes, what is the procedure? Swap pivot element and a of j. Swap pivot element and a of j. Pivot element is 9 and swap this. So automatically you will be getting 8, 9, 10. What is the final output? The final output will be 4, 5, 6, 8, 9, 10. Array is sorted. So this is one of the method of sorting the data items in an array. So array, you will be having fixed size which contains only the same data items, data types. So everything is integer, so that is stored in an array, and finally the elements in the array is sorted. This is just an algorithm. Based on this, you are going to code the program. So step by step, when I will be incremented, so what is the first thing to choose the pivot element? Pivot element will be your first or lower index, or a of 0 will be your pivot element. I will be at 0, that is nothing, your lower index, and j will be your higher index. Index is nothing, the position. After that, I plus plus, when I plus plus, a of I is less than pivot element. If it finds any greater element, stop. Next, same time a of j. So this is how you are going to call swap function. Function is same, but the parameters will be changing based on this. And now the whole thing comes under quicksort function. What are the parameters inside? Quicksort, you will be having array, next higher index, I mean lower index, next higher index. After that, the procedures are same. You are going to call the function again and again until all the elements in the data, I mean in the array, are sorted. Now the next topic, let it be after sorting. This is one of the type in sorting technique, quicksort. And normal sorting is also there, linear sorting, sequential sorting, or linear sorting. Now after sorting, the next procedure or next concept will be searching. Where the position, as I said the first, where the position, where the element, where means in the array, but where? Position. So we are going to find an element, search an element. Now we are going to search. So searching process. Searching will be linear searching, binary searching, and Fibonacci searching. So as of now, 3 types of searching technique is there: linear search, binary search, and Fibonacci search. Now linear search is sequential searching, one by one. As I said, you are having some elements 0, 5, 8, 4, 10. Compare, I need to search this, and I need to compare the same thing with first, second and third. It goes on. So based on that, so sequential 1, 2, 3, 4, 5, it goes on. Now binary search. What is mean by binary search? Binary 0 and 1. Why it is 0 and 1? 2. So binary search is nothing. You are going to divide the array into 2. First thing is partitioning. After that, if your element is this 0, 5, 8, 4, 10. In binary search and Fibonacci search, if your array elements are like this, you can't search. Why? We need a sorted array for binary search and Fibonacci search. For binary search and Fibonacci search, we need a sorted array. Until it is sorted, we can't do this binary search and Fibonacci search. So we need to sort it. The types of sortings. So based on that, we are going to sort this array, and only after sorting 0, 4, 5, 8, 10. Now I need to divide this. I need to divide this array into 2. Why? How? If I want to go to search this 5, 0, 1, 2, 3, 4, 5 elements, 0 to 4, I need to search this 5. So where this 5 is, you are going to divide this array into equally 2. That is nothing, 4 by 2. How 4? The first index plus last index by 2. First is nothing, 0, last is 4 by 2, which is equal to 2. So 2 will be the middle element. Based on the middle element, you are going to divide it into 2 and let it be 0, 4, 5, 8, 10. Now compare this searching element along with the divided arrays. So divided arrays will be, the second array will be larger, the first array will be smaller. So compare that, where that element will be in the first array. Again divide it, you will be getting again 2 arrays where the element the higher position. So this is what binary search is. Normal, we are going to divide, partitioning everything. Now here we are going to have Fibonacci search. This is little bit a new topic for many, but if you know, well and good. Fibonacci search will have search. So Fibonacci search, before Fibonacci search, we will have the series. What is Fibonacci series? We will have 0, 1. This is initial. Okay. Now let it be A, B, or Fibonacci series first, Fibonacci series second, whatever it is, our wish to choose the variable. Add the last 2. That will be the second, third sequence. These 2 are default. So 0 plus 1, 1. 1 plus 1, 2. 1 plus 2, 3. 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13, and it goes on. And it goes on till how many numbers we need. So before going to Fibonacci search, this is what our Fibonacci series is. And these are the initial steps for Fibonacci search. First, let your Fibonacci series among this is nothing, Fib 2, this is Fib 1, and this will be fib. Fib 2, fib 1 and fib. Now you are going to apply this one for this series. So fib 2 will be fib 1, fib 1 will be fib, and fib equal to fib 1 plus fib 2. The same you are going to apply here, and all the offset equal to 0. As of now, initializing offset equal to 0, and this is fib 2, this is fib 1. Fib equal to, sorry, this is fib 2, this is fib 1, and this is equal to fib. So offset 0, fib 2 equal to 0, 1, 0 plus 1, 1. Okay, initially this is the first step for Fibonacci search. From that I am going to apply this formula. Wait, I will say what is the use of this Fibonacci n. I mean fib is greater than n. We will have a series of array 5, 3, 6, 10, 9 and 1. This is Fibonacci, I mean this is an unsorted array. Using Fibonacci search, I need to search the array, search the element. So this is an unsorted array, we need to sort. So after sorting 3, 5, 6, 9, 10 and 1. So we sorted among any one of the sorting techniques, we sorted one array and we have this. Now we will have the positions. Here we are not going to start from 0, we are going to start from 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now we'll have this positions as Fibonacci series. We'll have this positions as Fibonacci series. First, I'm going to search the element 6. I'm going to search the element 6. 6 is at which position? It is 4. 6 is at position 4. These two are the major things as of now. Now we are going to substitute all the formulas here. Offset, let it be 0 again. Fib 2 equal to fib 1. What is fib 2? Here fib 1. Fib 1 is 1. Next, fib 1 equal to fib. Fib 1 equal to fib. Next, fib equal to fib 1 plus fib 2. Fib equal to fib 1 plus fib 2, that is 1 plus 1, 2. Now until this fib must be greater than n. What is n here? 6. Until this fib must be greater than 6. Go on, repeat the process again and again. For loop, offset 0. Next, fib 2 equal to fib 1, 1, 2, 2 plus 1, 3. Next, again offset 0, fib 2, 2, fib 1, 3, 5, 0, 3, 5, 8. We are going to stop here. Why we are going to stop here? since fib is greater than n, this condition. Once we get this condition, we are going to stop this table. Now come here. We are going to take another one more thing, I equal to minimum of offset plus fib2 comma n. I equal to minimum of offset plus fib2 comma n. Among this, which is minimum, is your value of I. So minimum of offset is 0 plus fib2 is 3 comma total elements 6, which is equal to minimum is 3. So minimum of 3, minimum of 3 and 6. So we are choosing I equal to 3. Now when A of I, now go for A of I. A of I is 5. So 5 is less than 6. 5 is less than 6. So if it is, our key is x, A of I is 5 and 6. If it is less than 6, fib equal to fib 1. Now change it. Fib equal to fib 1. Next, fib 1 equal to fib 2. Next, fib 2 equal to fib minus fib 1. So fib 2 equal to fib minus fib 1, which is equal to 2. Need not confuse, just you will be getting some series which will be either above or from the Fibonacci series only. Now this is this one 5 3 2. You will be repeating the values again and again, so you need not get confused and all. The same thing you will be getting. Just for formula we are applying this. For code purpose we are going to apply this. Other than that, just you are going to take, just listen here. Understood? This is the concept actually here happening. How it is happening? Using this code. Other than that, very simple to understand. Now when you are comparing this, we got again this one. We got a value 5 3 2. And what is the offset? Offset equal to I. I is nothing, 3. I is 3, and you have some values for fib 1, fib 2. Now again go for I value. I equal to minimum of offset plus fib 2. What is offset? 3 plus fib 2, 2 comma 6, which is equal to 5 comma 6, which is 5. I equal to 5. Now I equal to 5 means A of I equal to 9. A of I equal to 9 from the array. A of I equal to 9. 9 is greater than 6. 9 is greater than 6. Now go on. Now compare one by one. Fib equal to fib 2. Fib equal to fib 2. Next, fib 1 equal to fib 1 minus fib 2. Fib 1 equal to fib 1 3 minus 2 1. Next, fib 2 equal to fib minus fib 1. fib2 equal to fib minus fib1, which is equal to 1. Already we'll get this. Something above we'll be getting. So 2 1 1. What is I here? Offset, no change. Offset will be 3 again. Offset will be 3 again. Now again go on with I. I equal to minimum of what is offset? 3 plus fib2 is 4, comma what is n? 6. So which is equal to 4 comma 6. Among this, which is minimum? 4. When I equal to 4, A of I equal to 6. A of I equal to 6. We got it. A of I equal to 6. Only we have two conditions. A of I is greater than or less than that key. If it is equal to key means A of I equal to X means search is over. You found the element at the position 4. This is what your Fibonacci search is. So Fibonacci search, you need to know the Fibonacci series first. So after having this Fibonacci series, you need to know these formulas for coding purpose. For coding purpose, we need this using looping statements. So you use any looping, just go on with until your fib is greater than n. N is nothing, total number of elements, and after that you have I. How will you find I? So minimum of offset plus the fib2 value and the total. What is the minimum anyway? N won't be coming as minimum. If n comes as minimum, then somewhere you have done a mistake. So don't go for that. Just concentrate. If you touch Fibonacci search, concentrate and finish it, or else you will be under trouble. Because if you make mistake somewhere, it's like max. You need to recheck again from the first, double the work. So concentrate and finish it. So very easy if you concentrate it. Nothing is there, just you need to know the formula and two conditions. After finding I, whether A of I is less than X or A of I is greater than X. If it is less than X, what are the steps to be followed? If it is greater than X, what are the steps to be followed? Based on that, go with the table. Have this table, offset, fib, fib1, fib2. Have the Fibonacci series. The same, 0, 1, 0 plus 1, 1. Again, 1 plus 1, 2. 1 plus 2, 3. 2 plus 3, 5. 5 plus 3, 8 goes on until fib is greater than n. So this is what your Fibonacci search is. Sequential search, binary search, and Fibonacci search. So sorting. After sorting, we are going to search an element. So the key point for Fibonacci search and binary search is the array must be sorted. So after that, after sorting, you are going to search using this process, and this is what a few concepts in data structures. So from the word data, I am going to structure it, organize it, arrange it, and find it, where or display it. So this is what searching and sorting. Very simple concept in this data structures, but we need to concentrate and then we need to finish it. If you miss somewhere, that's it. So just go through these topics, go through these procedures. It won't be easy until you understand and concentrate. So it depends on your concentration power. That's why I'm stressing much concentration. So be on that, and these steps, just convert the same steps into code. This is one function, that is you are going to find I. So this will be under one function. Next, this will be all together in this Fibonacci search function. So once you finish everything, after that you are going to display it, print the result where the element is. So data structures, very important for computer science and allied branches. Hope my lecture finds you useful. Do well. Have a great day. Thank you.